Hello. I am sorry about that, oh, I'm late. Man, I haven't been late like this to a stream for a bit, but here I am. Alright. First of all, I gotta fix... What the hell is this? I'm white! When did this happen? There we go. Alright. Today we are going to be, I think we're mostly going to be finishing the, I think we're going to finish the basics of the C library today. So this is what we were working on last time, the big hash map. It's a hash map for 64-bit hashes that stores in a file. So I actually went and did some refactoring while I was off stream for this. Before I was storing all of the hashes in one section and then the objects and values in another. But I figured out that would cause more seeking since this is stored in a file. So we're going to store them together now. So I went and actually changed that, and I actually made a bunch of sections easier. Right here we just now write big blocks. Does everything work good here? It does, okay. Thought I might have forgot to switch stuff over after the gaming stream. So I'm just reading my own code here, grasp what we're doing. Yeah, so right here we're re-indexing the hash map when it gets resized. So right here we read out a hash value. Or what we end up doing here so HV is actually ends up being stored in this VBuff right here. So we're gonna create a uint64 called HV right here. Now we're gonna read a 64-bit int from this VBuffer, just like that. Now we have our HV right there. So then here we're going to seek to the position where we're going to set or write out the data. And then all we do is we just flip it around and we rewrite out this data. Yeah, so I'm actually going to need to flip the value back here when we write it out. If it's big endian, we need to switch the hash value back. This actually might be a good reason to just read it out like this. Reverse it in the hash value itself. So now we don't need to reverse this here, we can just write it back out. So OFP is our old file, NFP is our new file. We write that out. That's actually it. It's the re-indexing. And then we set the map size to the new map size at the end. That actually should be it. Now we need to do the actual adding here, which should be easy. Just call the index of empty. Gives us the index of that. And then we need to actually set the value and hash there. So we're going to seek. I have the file pointer here. I do not, so we're going to load up the file pointer. Oh yeah, and at the end we're going to add up the size. Okay, so we want to seek the index times TO size. And then first of all we're going to write out the hash, which big endian, and we're going to flip that around. And then we're going to write out the value. There we go. And then there's something I didn't do before, but right here when we close the file, we actually need to seek back to the beginning. And we need to write out the new size. So what we're going to do for that is we seek to h file, seek to 8. And we can reverse the memory right here. So I'm mostly going to be focusing and just try and get this done, because oh man, there's so much stuff I've been thinking about that I want to make with this. So we want to finish up Fatfish Online. That's going to use the WebSockets from these for the server. There's some UI apps I want to make. Oh man, there's some of the stuff I'm not going to talk about. I'm just going to do it one day, and I hope people like it. Alright, so I'm thinking about trying this now that we have all this. I'm gonna compile. Let's fix up the errors in it. Got to put the file pointer at the end there. There we go. Okay, wow, that actually compiled. Alright, let's try doing this. You know what, maybe I'll finish writing the next, because the next stuff isn't that difficult. Oh wait, actually the re-indexing is kind of difficult. So with designing this, I've actually been thinking about how would I design a server if I did this, and I actually decided as soon as you get to the point where you have over 4 billion entries of this and you need to store it in a file because you have so many entries, it's going to be slow as shit anyways. Like you're going to have like there's a whole bunch of other issues that come with storing databases with more than 1 billion entries and hundreds of millions of entries. I've figured out that the most efficient thing is most likely to do what you do with video games as well, and with like physics simulations where you chunk things. So instead of doing one giant a 1 billion size hash map, you split that into like 10 billion, or 10 million, sorry. So I'm still going to make this because obviously there are a whole bunch of uses for having hash maps that support billions of entries just straight off the bat in a single collection, but if you can, splitting that is so useful. Like, the ideal thing would actually be to have the hash maps each on a different server, each with their own RAM. I'm just thinking, I don't know what I'm going to do for this example. We're storing 32-bit integers, so I guess I might just store numbers assigned to strings. Bob, Sue, and Karen. And then we're going to have values. And these are just, they don't mean anything, it's literally just so that we can show how it's assigned. So then we're going to add these to the hash map. There's literally going to be no point to this, it's just going to show how big hash map can be used as an example. Not actually, isn't actually used for anything, it's just an example for how the code works. And it's not even like a complete example yet because we're kind of writing the example as we write the code for this. Okay, and I didn't think about this. We have no 64-bit hash function yet. So we're just going to use the 32-bit hash function and we're going to cast it to 64-bit to start. The hash function is part of random.h, so we'll include that. And then we pass in the pointer to the value. Alright, there we go. Now we'll add all these. Let's see if this works. So this should output a file. Map. 1 kilobyte. Yep, it worked. Interesting. Loaded map. Existing entries. This is going to print out how many objects are already in the map, and if objects are already added to the map or aren't already added to the map, then we're going to add them. Map loaded, 3 existing entries. Okay, so the basics of it is working. It's saving and loading. I think we're going to go ahead and do this next part now. Right here, reindexing, removing, find and remove. Hold on though. I'm gonna go and get some water. Alright, I will be right back. this wasn't muted. Well. Huh. You know what I was thinking we would do? We might do a music making stream one of these days. I like to just mess around in FL Studio, like an electric keyboard. We haven't done that before, but it's hard because you can't actually record the audio directly, or you don't get the low latency driver for the keyboard and playing. But I've actually tested it, and the quality isn't bad if I basically record the speaker output with the mic. So we might do that. I will see. Anyways, hold on. Be right back again. Alright, I'm back. Sorry for this stream isn't really well put together, but it is what it is. I've been trying to get a programming stream in besides the shader programming, and I haven't done it, so I said we're just gonna sit down and we're gonna do this afternoon. Even if it's not exactly organized. Alright, so now we're going to be trying to rewrite this reindex function. Yeah, this is going to be slow because you're going to need to loop through the whole map just to figure out if one is going to need to be reindexed. Well, you're not going to need to loop through the whole map until it finds one that's empty. Oh yeah, we're gonna need temporary memory for this. Basically, we're gonna copy the values, not just the hashes. We're going to need a buffer for this, but if this is recursive, we don't want to reallocate the buffer each time. Wait, what if allocating this on, instead of allocating this on the stack each time, let's just allocate a buffer. Just allocate a buffer to do this. Yeah, instead of allocating these each time, okay. File path buffer. Here we just free the buffer. Perfect. So now anytime we allocate... Oh, actually I think we can change up some stuff now. Yes, instead of seeking here, we can just read the whole thing, I believe. Oh, I don't know if seeking is better here or not. Because seeking might be slow, but if we block it into one fread call... Okay, I'm going to put it into one fread call. Now we don't need this second value either. Boom, there we go. I need to switch this around a little bit so it doesn't read this twice. Ooh, instead of reversing the bytes each time here, I could just reverse this hash. Oh, that's like... I might do that. I think that's actually better, instead of reversing the bytes each time. Oh no, because we still need to check whether or not this equals new long max. It needs to be proper value to check that. Alright, there we go. Now when we re-index it, we know we have a buffer here. Now we're basically going to rewrite this function, so instead of reading from memory, it's going to read from the file. So the first thing we need to do is we need to seek to this position we're going to read from. And we also need the file pointer. And we need the stride. And then this is going to be not unlike this, where it does fread, reverse bytes. Then we modulo by the map size, and if that modulo is our index, then this is something that can be re-indexed. And then we break. Alright, there we go. Then if map... okay. If I bigger than map size... then we need to seek back to the beginning, because we're now going to loop through from the beginning. Beginning is 16. And we repeat this same thing, but from the beginning, so I equals 0. And then bigger than index. So this is a cheaper way of doing 2 for loops, of basically writing for I bigger than map size, and then index is like I modulo map size. That's basically what we're doing in 2 for loops here, so we don't need to do a modulo each time. If I bigger than index or ends here, it shouldn't get here, but if it does, we're going to return. And now we can go on with this normal. Yeah, so what we do here when we re-index is we move the hash and the value over. And so if we actually have just found a re-index point, oh my god, I just realized a bug with this. When this re-indexes, it doesn't clear out the old position. Oh. So how this sets the hash pointer to the index, it's supposed to set this to the old index. So like HPI equals uint max. There we go. Here this is going to be different. We've already read this data here. We're going to seek back a little bit and write that with blank. Empty is going to be the empty hash value. Of course, if it's big Endian, we're going to need to swap the bits around. Alright, so we're going to seek back a little bit. We're going to seek to I. And we're going to write out this empty data. That way it sets this hash to 0, and at the same time we have the proper hash and the value read into HP. So then we're going to go and seek over to the new index, and we're going to write that data out now. This. There we go. Hold on. There's actually something I want to look up. Never looked up before. See, F right is stride or count bigger, better, bigger, faster, or faster. I'm actually wondering if the stride, effective size and counting on performance. The multiply size and count. No performance difference. Return the number of bytes. Okay, yep, no, that's exactly what I thought. Very nice. Alright, so now that we write out that new data, it's copied. We just call big hash map, re-index again, and now on this I index. So this will recursively go through and put the hashes back in their proper indexes or most optimized indexes. Hi, hello, iCustom or lcustom. Alright, and that's our main part of the remove function. Custom works. Alright, hello custom. Alright, so now to remove this hash, we seek to the position, and then we re-index it. Seek here. We need an empty value to fill in, so we're just going to set. So empty hash is the max value, u long. This is every bit set to 1. because we need some way of saying what hash is no hash. Beginner coding, want to learn how to do a while loop. You can just write while true, and that's the simplest while loop you can write, just like that. Or you could do it as while 1 in a lot of languages, because 1 is normally the same thing as true. Alright, and then after removing the object, we reduce the size, the count of objects, and we re-index, because we can now put some other hashes at this index. Awesome, okay, there's our remove function. So the next functions like find and remove and all that should be very easy. I don't know if I'm going to do enumerate. Maybe. Actually, yeah, probably good to implement enumerate. I just realized, does it say, yeah, ulong max. And then, yeah, this part's going to be super simple. We're just going to be replacing, we're just going to be putting big in front of everything, because everything else should automatically work. I can't wait to finish this big hash map. Then we're gonna move on to, I think we might actually, oh man, there's so many things I want to do. Testing hash functions. Oh man, I kind of want to, I think we're gonna go ahead and do the WebSocket and sockets and get the Fatfish server up and running. Keep copy and pasting that section, forgetting UL long isn't in the clipboard. Oh, and what does this do? This compares. Oh, this code looks confusing. Yeah, that's what I'm talking about. This is just kind of something I need to write now. It's like really difficult code that I write now, but then once I've written this, it's so much easier later on, because I can just use and call on this code. Using integers, I made an integer 0, do a loop. If it is less than 10, keep looping. I made it add 1. Perfect. You have made a for loop from scratch with a while loop. Hold on, let me... Okay, this is actually awesome. First of all, I'm an idiot, and I didn't replace this. This is supposed to be, HBuffer now. Yeah, this is supposed to be HBuffer as well. Okay, this is so nice, though. This means now that whenever I call index of, to find the index of a hash, it reads the whole data into buffer, which means that you can just automatically get the value after finding the index of the hash. That is huge. So that means here, when we do our memory compare, how we would do values, we can do HBuffer plus 8, and it'll be our value from the last index. That's so, yeah, that's really nice. That's optimized as well. And then if it is the value we're looking for, we can remove it. Perfect. Alright, now we're on the last function, enumerate. And yeah, this is confusing, especially because this is normally stuff that you don't do. This is normally handled for you by the language, Java, C++, C#. They all come with hash map, dictionary, implementations that do all this stuff for you. Yeah, so this is just going to be slowly seeking through. I'm glad I don't have to do that. It looks sort of confusing. That basically sums up programming. You don't have to do things unless you want to. And I mean that negatively. I mean like you dig your own grave. Yeah, so actually I can just document here returns current index and out and stores hash/value in map buffer. Well, I actually need to write out a lot of this function. I don't need to write it out, but good to write out a lot of this. I need a lot more local variables for this than I thought I needed. Okay, here we go. We're basically done. So now I read out the hash from that. If the hash is a Bulong max, which means no hash, then we've read a hash value, in which case we return I+1. Oh, I should actually add something that checks whether or not it doesn't need to seek if it's currently enumerating. It doesn't need to seek if it's currently enumerated. That basically means we only need to... you know what, never mind, because that also assumes that there aren't going to be any add or remove calls or anything between enumeration. Yeah, this should be good. I also should add a check here if index bigger than or equal to map size return. Because if they do add or remove, but yeah, it's fine here. Here it might seek to outside the file. I guess that's still fine. It's no big issue. Okay, let's do this example. So if the size is 0, it's going to add the objects to the hash map. Let's do this. Hash map. We're storing 32-bit 4-byte values. File map. The file is created if it does not exist. If the file already exists, data is loaded. If not, a new file is created. There we go, that's better. Alright, if our map is empty, add entries. Print out entries. So while index equals big hash map, enumerate, what's this gonna look like? Yeah, then we're just gonna pass in the index. Not equal. Yeah, so this will work, but now index will be 1 here, which won't be the actual index, unless, I guess we can just do subtract 1. Yeah, this is actually going to be hard to understand even for somewhat experienced programmers because it does not explain much, or it's a bunch of pointers. You have to actually read the documentation of this and see that the enumeration outputs it to map buffer to realize that it's reading from the buffer because enumerate output to it. Of buffer values after first 8 bytes. Alright, let's see if this works. Map loaded 3 existing entries. Number 13, entry number 45. Okay, so you know what I'm going to do? I'm also going to print out the hashes of each of these. Maybe. Yeah, I might make a macro to do this, so I don't need to keep calling this. You know what, maybe we'll put this in an array. And you know what, maybe we'll make the values the actual pointers to the string, so then it can print out the associated, yeah, but then that actually wouldn't work if this is reset. Yeah, we'll do an array. Alright, so now when we add it, we're going to print out adding Here we go. Alright. Now I'm gonna delete the existing map file to just to test this out. I wanna see if there's an indirection. What's going on? My cursor disappeared. Oh god. There we go. It's back. That was weird. It was making dinging noise, and I think that's supposed to be like that. Yep. And this is supposed to be like that. Hold on. I just want to see something. GCC variable array initialization. I almost think I remember some issue with GCC. There we go. Okay. Variable array support is marked as optional. Okay. You know what? I didn't realize that. You know what? We're gonna go through. What do I have defined as a, I think, the base 60, oh no, so I think we're going to have to go through a bit of this code, and we're going to have to replace the bits with variable length array that have, right here, variable length array. There's 256 values, I remember. We're going to look for arrays like that. I actually think the only other one is reflection here, where it defines an array right here. VA args. I think we can apply count. We did count right there. That should do it. I mean, that's the thing. The only real difference, I guess, is you need to count the number of items in the array before you do them. That's not a big deal. Map loaded, 0 existing entries, adding Bob, hash 1BB, value 0, Sue, hash 42B2, value 5. So we're going to check the hashes and values line up. So 1BBA, value 0. Here we can see 1BBA, value 0. 42B is value 5. We can see 42B with value 5. The map is working. Awesome. So our big hash map is working perfectly. Beautiful. Alright, there's our big hash map done. I think we're going to go ahead and we're going to do the socket programming next. We're going to make a little client and server example. Oh, wait, I just noticed I forgot to comment this little section of the code. Free memory closed files. Use that big hash map. There we go. Now I'm deleting all the extra files that you don't need here, so it doesn't take up extra space. Okay. Alright, we're doing the socket next. So I'm going to use this, I already have cross-platform socket here. We're going to use this as a starting point, or as a base, but we're going to refactor a lot of it. One of the things I, for example, figured out is that this non-blocking socket system, actually, if you use it for games, this is a super interesting thing I didn't realize. So just using this, what this does is it loops through all of the connections in an online server. Like, for example, if you have a bunch of different players connected, it loops through the connections and it checks each connection to see if it's received messages to process packets. That just seems fine, right? Like, each frame you'll loop through, you'll figure out which packets to process. With this naive system, a whole bunch of games have used this, by the way. This is like an issue in games today. There's people still doing netcode for games to have this. So this seems just fine, because you do this everywhere. You loop through one by one. If you think about how this actually works in your networking, when it receives an event from the player, like a message, it might, for example, shoot another player and kill another player. So, if every time it runs a frame, it checks, let's say, player A and B, let's say player A is first in the list. So each frame, it actually checks for player A's messages and packets first, before player B's. So if you imagine player A and B both shoot each other at exactly the same time in a shooting game, it both sends their messages to the server at the exact same time, with the messages saying, we shot each other. Every single time that they shoot each other at the same time, player A will win every single time and get the kill, because it'll be checking player A first in the for loop and going, oh hey, player A received an event to shoot player B, we shot player B and he's dead. And every single time it'll basically check player A's shooting before player B. So this is actually a super easy fix. Each time you run this, you swap direction that you loop through the list. So one time you run it, you go forwards like this. The next time you run this, you do a for loop backwards. So that next time, it'll have a different player. This time it would do B first. It would do player B would get the kill instead of A. So that way, it still does have a little bit of behind-the-scenes advantage, where one player actually does have a chance of receiving the message before the other. But at least this way, it's switching between them and it'll average out to being even. With this method, it doesn't average out to being even. You can actually, this is actually a thing in RuneScape. I believe they fixed this. Unique identification number the player possesses. It previously determined the priority between two or more players when simultaneously performing tasks throughout RuneScape. The update on September 2013 removed the system. A random player ID is assigned to a player upon logging into the game, and it changes each time they log in. Prior to the player ID system, priority between player was based on the player's IP addresses. So you could actually get an advantage by getting a specific IP address, which is super interesting. Players could approximate their player ID by having a player and having them run. The delay between that other player moving and the player's character moving was believed to be caused by the player's player ID. It was longer. Like, man, it is crazy how much little stuff like this, like just what direction you do a for loop, can have on the effects of a game. Like, it's honestly so cool. Or a simulation. Like, that's the thing, is these games in the end are simulations. I'm just using this system info file as a template. We're just going to delete everything now. There is going to be a lot of code here to convert. So what I'm doing for now as well is this is going to support Linux, but while I'm on Windows right now, I'm only going to be focusing on the Windows. And then one of these days we're going to go over and boot up Linux, and we're going to fix up all the little issues with the Linux version. But basically all the functions are the same. You can see there's just little stupid stuff like this, where on Linux you can just use the close file function on the socket, but on Windows you have to use the close socket function. Like, for some reason, Windows just has these little stupid things where they've renamed it. Or you can see here instead. Oh my god. Windows is really weird because it has a bunch of the same things here as Unix sockets, but then they've renamed it for some reason. Like, they made it the same, but then they changed it just for the sake of changing it. Fucking Microsoft. Linux. Huh. I don't think, do I have a, I don't think I made a function template like that. No, I didn't. So we might actually make a function for this receive callback. Again, I'm gonna declare that though, just like this I function is a, yeah, so we have these function declarations that I did before. What ended up happening is we basically only used these, the 1 arg and 0 arg. So we're gonna do that. I'm gonna rename them to something different though. I feel like 0 arg function is a really bad name. Maybe just 0. I mean, I guess not. With the full argument thing there, that's not that bad. 0 argument, 1 argument. I'm good with that. And then what is our, what is this gonna look like? Instead of I function. I feel like owned function is a weird name. Function call, maybe? I know these are called delegates in C#. Function binding, maybe? Yeah, I think function binding is a good name for it. Now what do I call this? This is just used for class functions. Along with pointers. Oh, wait. You know what? I think I'm going to do this as its own function. I don't know. You know what? We'll leave these because we're going to use this. I feel like I should put some commenting here though. Helpful. Defines, I don't know, function type definitions. Alright, so yeah, I was looking at this I function receive. the pointer argument of this receive is actually just a pointer to this same socket, which is incredibly stupid. I don't know why I designed it like that before. I know actually why I designed it like that before. It was because I just used the I function for everything, this I function structure, because I could just pass it in and just have it called. We're gonna start with this just copying this chunk to begin. Can I just call this IP address? Yeah, I think I can. Oh, okay, this seems so stupid to have this be a pointer. Can I just do type define address info? I think I can do this. I think this is a thing. We're gonna try that. Hold on, I'm not gonna do anything else. We're gonna, until I test this little thing, we're gonna create a little example for it. I'm just creating a new Visual Studio project right now for this. Warning, macro redefinition. Oh no! Oh, Windsock uses the same macros. Ooh. What do I do for that? Oh no. I think I'm just gonna need to change the endianness macros. Yeah, I honestly can't think of anything. If they use those macros, there's no way of there's no way other than renaming these. So what should I? Little endian with an underscore like this. What did I do here? I had the same thing. How did this not conflict? Wait, I'm so confused. Wait. So, hold on. I have the exact same defines here. And it never gave me this error before for the macro redefinitions. I'm so confused how I'm getting these now, but let me see if anyone else had this. WinSock 2, big endian redefinition. These guys got very similar. Stops Windows.h, including WinSock. Oh, the problem is caused by including Windows.h before WinSock 2. Rearrange it. Holy crap. That is such a stupid bug. Oh my god, so that means if I put this right here below, it should fix it. What? Fucking Windows, man. So wait, you include... How did this guy figure this out? How did... Following the sample from the SDK from 2008, I tried to move that code into the DLL project. I have to include Windows.h for to include the DLL entry. I need to include WinSock 2 to make my WinSock calls. However, compile, I got a large amount of errors that conflict between WinSock 1 and WinSock 2. Evidently, Windows.h includes WinSock.h. What's the head? Include WinSock 2 first, then Windows.h. So is this something you're just supposed to know? Like, if this... How did these people on the forum figure this shit out for the first time? Stops Windows.h including WinSock.h. You can also define Win32 mean and mean. Am I defining Win32 mean and mean? I am! Oh! Wow, that is such a stupid bug. Or like, is that even a bug? Because that's like... That's more just like Microsoft programmers designing shit really badly. Oh my god. Not the first time that's happened, but... Okay, let's see if this IP address type definition works. Is these types equal? So we're going to compare the size of them. Just like that. Use of undefined type address info. What? See definition. Wait. Undefined. See declaration. It's undefined, but look at the declaration of it. Undefined, but it's declared. Let me guess. It doesn't like about the structure there. No, I wonder what this is. That is weird. Maybe if I remove this. Huh, that's weird. I wonder if it's not actually a structure behind the scenes. Something like that. I don't know. Anyways, we don't need to compare that last one, I don't think. Are these equal? They are. Okay. Good, we know this works. Now we're going to start writing our actual socket class. And it's going to be exactly the same as here. Just a bunch of flags, whether or not it's blocking, TCP, or if it's a server. And then our one argument function for receive. This will be called when... Oh, wait! I just realized I am going to want a pointer here. For some data to pass along with receive. I don't know what to call it though. You know what? That actually is a use for this function binding right here that I was going to make before. I'm still just going to do the one argument function, and then we're going to do a value called owner that is passed in as the argument for receive. Or what should I call that? I don't know if I call it owner. Receive argument. I think receive argument's probably straightforward. Look at this. Oh yeah, so first of all we need to initialize this, the WinSocket on Windows. How to do this. So one of the things I've been thinking, so there's a few things like this where you want to run some startup on like program startup or something. For example, like I might do some math, I might pre-calculate some math tables or something. And I don't want to have to call, or I would like a system where I don't have to call each of these individual functions right on the entry point. I'm looking at doing something like call them manually after the entry point. I have these entry point macros here, and I'm actually thinking there's some way that I should be able to call those, like automatically register something to be called at the entry point. Like, I think maybe I could create a linked list. Like if I create some function, it's like sock startup, then I should be able to do something that's like I think I should be able to assign pointers to that, like that, and then link to the pointer like last startup call. And then like, yeah, I should be able to create a linked list of these function calls. The whole thing is, though, is that efficient? I don't think it is. I think the most efficient way is still just to do these macros. So that's what we're going to do. At the end of the day as well, you should be looking in these files to see what startup function should be called and when anyways. Clean up socket system. Is that a good function name? Maybe just initialize socket. Do it like that. It's so weird though having that do nothing on Linux, but the way it is. Alright, there we go. And I add that extra stuff for the socket polling list, but I'm not going to do that until we actually do the socket polling list. We don't have it yet, so... Alright, let's initialize this IP, make this IP a initialization function. Oh yeah, I should document this as well. Initialize and clean up socket system. Initialize socket system called before using sockets. And now we're going to rewrite this with our modern naming and everything. Wait, what is this doing here? Mem set 0. Why do I have this code here? Oh no, I can't remember why I did this. So this sets the address data to 0, but why does that do that? Oh, so we're going to need to actually check if this is 60 or IPv6 this time. Oh, interesting. So this is, yeah, this is for the server when the address string is null. Sets this data to 0. So the socket's actually 0. It's so weird how it doesn't set that up by itself. We're gonna take that away and we're gonna see if it works anyways. I feel like that might be a bug that I like fixed on Linux or something. I'm not sure. Why is that there? Address string resolving hostname process. Address string is null, and a host, then any IP address is selected. This is initialized for server. Returns true on success. I'm going to leave that commented out there just in case that is something. I wonder if I should do the server. I think I should do the server accepting and initializing code first. I think it makes sense to do the server before the client. Alright, I gotta think about how I want to design this. The nice way to do this would just be to have a single socket new function. And then I think you would pass in IP address like this to connect to. And if the IP address is null, it automatically sets one up for you for the server. The other nice way would be oh, okay, actually, you know what? I don't need the address right here. I just need whether or not it's TCP. Wait, what do I need the IP address for? Yeah, so just use the IP address to get the family, whether or not it's IPv6 or not. Well, it's getting the protocol. think we will do it like this. So this will automatically initialize if it's a server as well, and bind it to the socket. Or, no, I think it'll just initialize it actually. Wait, so if this is initializing it for a server, does it look like this connecting? It's very similar, right? Yeah, it's basically the same. It calls connect instead. I wonder how I would tell if this is a server. Maybe look at the address, just like how it does right here. Check whether or not it's all 0. Yeah. Let's do that. Terms. IP address is server listening. I don't know what to call it besides server listening. I can't believe you would have to memset this to 0 yourself, but you might have to. Seems crazy to me, but we're going to test it right here. Oh yeah, we're also going to add a function for checking if it's IPv6. Oh, this says, yeah, we're going to do all the things. We're going to do TCP. I think it's AFINet. Should actually be able to see right here. Yeah. If equals INET6. So we need to apply different logic if this is IPv6, depending on this. So yeah, SIN6 address. I guess it's socket SIN6 address. Like what weird naming. There we go. Comment out all the other code just to test this. We're just going to do this to begin to make sure it works. This will create server socket on port 999, that's TCP. Print out if that's a success. Do the exact same thing for the other one. Except for this one, we're going to do localhost for this. It's localhost. Alright. I'm going to create a function for printing IP info. I forgot, we're going to need to initialize the socket system first, like that. Okay. So IP, TCP, IPv6, server, that's what we're going to output. So this isn't going to be part of the example. I'm just doing this to actually test the API itself and to make sure this part works, or if it actually has issues without setting it to 0. Syntax error. Undeclared identifier socket. Maybe it's the Windows lean and mean. I'm actually curious, how is socket undeclared here? No, yeah, it doesn't have barely any of these structures. This is weird. What? So this has all the socket types, but it has the macro redefinitions. I'm so confused. Maybe I need to include WinSock 1. I guess we're just going to need to find a way around this. Windows.h exclude WinSock. I think someone in that forum post we saw said there was prevent inclusion. Here we go. You can try to always include WinSock.h before Windows.h, or you can define Win32 lean and mean. Don't recommend using lean and mean for optimization. Correctness. I have lean and mean. Try removing lean and mean. Oh, interesting. WinSock 2 doesn't work with lean and mean. That's weird. So if I include lean and mean, so wait, that begs the question. If it's lean and mean right here that's breaking it, what if I... So lean and mean isn't enabled right here. That's... I don't understand. I fucking hate Windows APIs, man. Like, actually, these new Windows 8.1 like kits are so fucking bad. Holy shit. Next stream might be on. So, oh man, here's the thing though. I have never had a stream on Linux where I haven't dropped frames. Like, there is still a bunch of stuff like streaming and video encoding that just works so much better on Windows. I wish devs would support Linux more. So what am I going to do about this? I mean, I guess I might just rename the endianness. I mean, I don't know what else to do. I mean, if these macros are already used in other stuff as well, you know what? The macro redefinitions are just warnings, though. Oh my god, okay. So you know what? I think I can do a trick for this. So, we actually know that it's going to be little endian on Windows. So I think what we can do here is we can temporarily undefine it, and then we can redefine it. Just like that. Does that work? Wait. Running macro redefinition. See previous definition. No, wait. Oh yeah, okay, wait. Undefined. Undef, big endian. that is how you hack it with C. That is how you get no compile. So just undefine the already existing, undefine them, and then redefine them. Perfect. That's all you need to do, right? Holy shit. Alright, let's get to these actual issues now. So how do I access the address info here? I think this might actually be... Wait, so does this let me actually do dot like this? I don't freaking understand. Let's see. Wait, type def pointer type in normal. I think you can type define pointers. Doesn't play well. Oh, so it's specifically used to actually hide structures. So in my case, I don't want to hide this structure. Actually, hold on, let me see something. What if we just did... No, we're not going to do it like this. Do it the proper way. How do I... Oh, there has to be a way to like combine this. This is just a pointer though, I guess. There we go, this should fix it. Well, parameter is not a pointer. What? Parameter 1. Oh, it's supposed to be and. Oh, there we go. Awesome. So those linker errors are normal. That's because we haven't added WinSock here to the list of used libraries. I guess ws232.lib. Let me see. We're gonna put little notes here at the top. Yep, that's correct. Alright. See if this works. Alright, it returned true. So these successfully created. And then it failed to print out their info. Let's see which it failed to print out. I'm guessing it's the is IPv6 here. No, I don't know. Alright, hold on. I will be right back. Alright, that'll be it for the stream for me. Sorry about that. I'll maybe be back tonight. Well, actually, I'm definitely gonna at least be back for an hour to do daily shader programming. Other than that though, I will see you around. I hope you have a good day, wherever you are. Thank you for watching.